Woohoo! We are recording. This is Math 75 9.3 Part 2. And I have a lovely helpful card in case you'd like to take a little screenshot of that. I've written out the definition of the derivative. F prime of x equals dy over dx or dy dx, or the derivative of y with respect to x, and that's equal to the limit as h approaches 0 of the difference quotient. Yay, math! We're going to need this because we're going to be using it in 9.3. Now, a lot of people gnash their teeth and get very despairy in 9.3. And what I'm going to tell you is, starting in 9.4, I promise you there will be shortcuts. You will be able to take derivatives much faster. And in fact, if you've studied calculus before, you know this is coming. But for 9.3, we're going to do it the old, like, 400 years ago way, where we're actually going to work through all of this. So keep this handy and let's do some math. Woohoo! So, first problem. Example, use the formal definition of the derivative. So if you see someone say this, formal definition of the derivative, then you know they mean this. This and that, that's what they mean. So if you do know the shortcuts, that's awesome. If you know the shortcuts, you know, pardon me, Godzilla's still here just off to the side. You know that taking the derivative of this would take 2 seconds, maybe even 1 second, right? You would know the answer without even having to work hard. But it's important in the beginning to use the definition because the definition does come up in other settings. So I want to make sure you know how to use it. So let's give that a try. The derivative is given as the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, if we were taking a full calculus course, then I would expect you to have that memorized. But since this is a calculus and finance and all these other things class, I will give you this form on your test. So I'll remind you what this looks like. Okay, so let's go ahead and work on it. So this is going to be very reminiscent of what we did when we did the difference quotient. So finally you're going to see, oh, that's why you wanted us to practice this. So if f of x equals 2x plus 3, I need to find f of x plus h. And remember, that just means to put x plus h anywhere I see x. So if this is 2x plus 3, then this becomes 2, and not just x, but x plus h plus 3. And that's equal to 2x plus 2h plus 3. Okay. Now, I don't recall what the colors were way back there, but I'm going to go ahead and make the f of x plus h the pink one. And I'm going to make the f of x the blue one. And a lot of people ask, well, how are you always doing pink and blue? Well, they're very high contrast together. So it's, even if your video monitor is a little wonky, I believe those show up as different colors. So I've got the pink and the blue. So my derivative is equal to, now this is very important. A lot of people leave this out. They're like, oh, I'll just put this in at the end. But this is an important part. So I've got that. I've got my pink piece, 2x plus 2h plus 3, minus my blue piece, 2x plus 3, all over h. There's my blue. And here's my pink. So once I've set this up, the next thing I need to do is actually simplify on top, get rid of those brackets, do the subtraction. And again, do not forget the limit. The limit is really important. And I know it just feels like this extra thing, but it's like, you know, it's like your elbow. You don't use it all the time and it gets in the way sometimes, but you don't want to just leave it at home because it's going to be important. All right? See why I should probably script these things ahead of time. Yes, I see. Okay, 2x plus 2h plus 3 minus 2x minus 3. Okay, so that's the limit. As h approaches 0, the 2x's cancel, the 3's cancel, and all I have left is 2h all over h, which is the limit as h approaches 0. And here I can cancel my h's very simply. This one's a really nice one. And it's the limit as h approaches 0 of 2. Now at this point, you're going to ask me, what the heck does that mean? And the answer is there any h in this? And the answer is no, there's no h in this. So does it matter what happens to h? No. Where does 2 go? 2 stays where 2 is. 2 is a constant. The whole thing is just 2. And that is the derivative. Now let's answer some questions. Okay. Find the instantaneous rate of change of the function at any value. This whole thing is f prime of x, which we know is 2. And I said at any value because it equals 2 no matter what x is. So it's always 2. Now, why is that? What's going on? What is this function? And the answer is, let's take a look. If I do a really quick graph of f of x, if f of x equals 2x plus 3, well, do you recognize that that's a line? And it's a line that goes through the point 0, 3. And I can plug in some other points. At 1, it would go through the point 1, 5. And so this graph is going to look something like this. Ooh, I'll use green for a green ruler, green line. So what's the slope of a line? Well, the slope of the line is just m, right? Does the slope ever change? No, the slope stays 2 the whole time. So what's the derivative? Well, the derivative, which is just the instantaneous rate of change, which in this case is the slope. In fact, if you're a line, you are your own tangent. This is the tangent line to itself, because it is already a line. And so slope is 2. Derivative is 2. The instantaneous rate of change is 2. What other interesting things are going to come up? Find the instantaneous rate of change of the function at the value x equals -4. Dum, dum, dum. The instantaneous rate of change of the function is f prime of x. The derivative, which we already know, is 2. It's always 2. Find the slope of the tangent at the value x equals -4. The slope of the tangent line, that's the derivative. The derivative is 2. You're right. Would your answers to C and D change at a different value for x? And the answer is no. F prime of x equals 2. It just always equals 2. And then the next question would be, well, are there any derivatives that do change? And I am so glad you asked that. Although there's a chance that you will not be glad you asked that. But, you know, you're young, you've got time. Shall we spend a little bit of that precious time doing some really super fun calculus? Well, I know, not everyone would necessarily choose super fun calculus. However, you can impress people with this. Honestly, it's like having best friends who are, you know, super monsters from monster movies. Because if you tell people you can do calculus, for the most part, they're going to be very impressed. So this is definitely excellent. And as soon as you're done watching this video, I mean, I think you can start claiming you can do a little calculus. You can at least understand it. Or at the very least, you can say, I didn't fall asleep when someone else was doing calculus. Okay, you guys ready? So, do you recognize this shape? Hopefully you do. Hopefully you recognize. In fact, I'm not going to put it on a little card. I'm going to point out that this is a parabola, right? And it opens upward. And so my question is it going to be like a line? Is it going to be just one tangent everywhere? And the answer is no. Because over here, over on the left-hand side, like at this point, the tangent line would be there. Approximately. It's really hard to draw tangent lines terribly well. This is why calculus is good, because they're really hard to eyeball, but I'm going to do my best. Tangent line down at the bottom would be like that. Let's see, if I pick a point like right there, that one's right there. If I pick a point like right there, again, it's very hard to eyeball. It's one way you can think about it is if this were sitting on a table at this point, I'm drawing the tabletop. So you'd see kind of how it's resting on the table. So for this one, I'm going to claim that there are a lot of possible tangent lines. Right? Those are a lot of different possibilities. Depending on where you are, you can describe at this point, you're kind of headed downward. At this point, you're kind of headed, you're just kind of stopped in the middle. You're coming around and you're kind of stopped for a moment before you go back up. At this point, you're already heading back up. So there are lots of different tangent lines. And that makes sense. If we were talking about this from the perspective of stock market, right here, we would be on a downward turn, which hopefully at this point from all the discussions we've been having wouldn't necessarily mean you would have to lose money. There are lots of ways to earn money, make money off of a downward swing. If we were at this point, things are kind of sitting in the middle. They're kind of turning back around. And at this point, things are heading back up. So you can imagine lots of different tangent lines. So the definition of the derivative, this is going to be a slightly more exciting prospect. Shall we get into it? I know. You can't wait to do calculus. Now, I've written the definition of the derivative in terms of f, so we're going to have to rewrite it in g. G prime of x, or the derivative of g of x, is equal to, and then you could, if you wanted to, write dy over dx. I'm not going to do that. It's the limit, as h gets very small, of g of x plus h minus g of x all over h. And remember, this is just that slope. That's that rise over run. That's all it is. It's the difference quotient. Okay, so I know g of x squared minus 4x plus 6. Next up, I need to find g of x plus h. Now remember, everywhere you see an x here, you're going to see an x plus h down below. This is going to take a little work. We should probably simplify this. So let's see. Hopefully at this point you have this memorized. If not, you'll use FOIL. This will be x squared plus 2xh plus h squared. So that's going to be, what colors did I use before? I used pink and blue. So I'll use, this part is right here. And then I'm going to keep going, multiply through by the -4, -4x minus 4h plus 6. Notice that this is not just take g of x and add an h on the end. Oh my gosh, that would be amazing if it were that simple, but it is not. Okay, there's our 6 that hangs out there. So you see it's got multiple parts. Generally speaking, when you multiply out here, this will usually not simplify at all. It's just going to get really big, and we just got to deal with it. Okay, so ready? So I want, let's see, what did I use? Oh, I used pink for this in the previous one. I'm trying to be consistent. I'm going to use g of x plus h minus g of x. I'm just rewriting. Oh my goodness, I didn't give myself, after admonishing you not to do this. Oh, seriously, physician, heal thyself. I'm not a physician, so that's moot. Here, let me say. I should have told you to look the other way. Look. What did I forget? I forgot my limit. You gotta have the limit in there, or else it's just the whole thing just fall. I mean, the fabric of society will just dissolve in front of you, and it will be chaos. And don't get me wrong, chaos can be fun, but not this kind of. You don't want that kind of chaos. No, really, worlds exploding, and it's just ugly. Okay, so I need to do. Let's see, here are my colors. There's my g of x plus h is going to be pink, and my g of x is going to be blue because that's what I did in the previous one. So I'm going to say limit as h approaches 0 of, give myself lots of room and a big bracket, and I take this whole thing and stick it in here. X squared plus 2xh plus h squared minus 4x minus 4h plus 6. Oh my gosh, we made it. Phew. I know, I'm not tricking anyone with the cute colors. I know this is not simple. This is really not simple. This is probably the hardest thing you will do in this class. G of x, which we were given, x squared minus 4x plus 6. It seems so innocent and sweet comparatively, doesn't it? And then the whole thing is over h just to make our lives harder. Okay. Deep breath, we can do it. Courage. The limit as h approaches 0 of big thing, x squared plus 2xh plus h squared. There's that x plus h, the quantity squared, minus 4x minus 4h plus 6. See how h is really all sprinkled through? Again, you can't just add h at the end. Now, here I've got to be careful. I know things are going to cancel, so I will be able to check this. But remember, this minus has got to change the signs of everything inside there. So I get minus x squared plus 4x minus 6. Now, this is a big old mess. So you'll probably want to do something to be able to connect the dots, see what's canceling. I'm going to draw a single dot under the x squareds because they cancel. And I'm going to write 2 dots under the 4x because there's a minus 4x and a plus 4x. And then there's a plus 6 and a minus 6. So 1, 2, 3, 1, 2, 3. You can use other colors or other ways of marking this down. So I've got the limit. We're in the home stretch. We can do this. Of, that's gone. So I've got 2xh plus h squared. That's gone. Minus 4h. That's gone. That's gone. That's gone. That's gone. Ooh. And then remember what the next step is. So it's been a while. We have to reduce, but in order to reduce, we have to factor. So I'm going to take the limit as h approaches 0 of h times, factor out the h, 2x plus h minus 4 all over h. This is the limit as h approaches 0 of, cancel the h's. We're almost there. Oh my God, can you just taste it? Now, this is going to be a little weird. Limits need, if you just write just the 2x plus h minus 4 without the parentheses, then the limit only applies to the very first thing. It's a weird part of math. So if you get a long argument in front of the limit, just keep it inside parentheses. So now what do? Well, as h approaches 0, 2x stays 2x, minus 4 stays minus 4. What happens to the h, though? The h, I'm shrinking. Oh, no. Bam. So what the heck does that mean? Well, it means, back up here in the picture, the derivative gives you the slope of a tangent line. So sometimes the slope is negative, right? This is decreasing. Sometimes the slope is 0. Sometimes the slope is positive. How do you know? Well, it depends on what x is. Depending on what x is, you take 2 times x, subtract 4, that gives you the slope. Woohoo? Kind of. Yeah, I feel how tired you are. Okay, we've got one more page. Hopefully it helps and doesn't hurt. But let's give it a try. So at the very top, I'm going to write our derivative from the previous page. G prime of x was 2x minus 4. We're going to need that for this page. Okay. Okay, we don't need this card anymore. Find the slope of the tangent line at x equals 2. So we want to find the derivative at x equals 2. Oops. Oh my goodness, where is my brain tonight? Obviously, I left it in the other... Oh no. I left it in my other pants. Okay, there we go. Okay. G prime of 2 is 2 times 2 minus 4 is 4 minus 4 is 0. So the slope of the tangent line at x equals 2 is 0. So where is that? That is where the tangent line is totally horizontal. So we now know that when x equals 2, we're at the vertex. So this is an interesting new technique we have, because now we have a way of finding the points where, like you have, in this case, a minimum. This is going to be useful. Okay, part C. Use your answer to find the equation of the tangent line at x equals 2. So we know the derivative at 2 is 0. So that's equal to the slope of the tangent. To find the equation of the tangent line, I need a slope, but what else do I need to get the equation of a tangent line? Or any line, really. Any line, I need a slope and I need a point. Now, what's happening at this point? So we know that right there, x equals 2, right? And we know that the tangent line is sitting there and the curve itself is there. And that point is on the tangent and the curve. So weirdly enough, we have to find the original value. What is the original value when x is 2? So let me bring us back to our original function. Our original function was x squared. So g of x is x squared minus 4x plus 6. G of 2 is 2 squared minus 4 times 2 plus 6. So we actually have to find not just the derivative, but the original function. Let's see what this is. This is 4 minus 8 plus 6, which is equal to, I can't add 2. So that's the y value. So this point right there, x equals 2 and y equals 2. It just happened that way. I didn't intend it that way. It just happened that they match. They won't always. So I know that my slope is 0 and my point is 2, 2. That's the point that they share. And the reason I knew what that point was because it's on the original function. So I can actually go in and plug it in. If the slope is 0, and x and y are 2 and 2, I can use either of my equations. I'm going to use y minus y1 equals mx minus x1 because I'm old and that was the way we were taught. If you want to use y equals mx plus b, go for it. We'll have a race. Now we got an interesting situation. When I multiply by 0, what happens? 0. So the equation of the tangent line is y equals 2. Why is it this weird format? Because it's a horizontal line. And the equation of a horizontal line is y equals some value. Now, will this always happen? No. So if you remember, we got lucky and I gave you this one. In your other homework, you're probably going to get this one. In which case, you're going to do all the same work, but you're going to end up with like y equals 5x plus 3 or something like that. Okay? Find the instantaneous rate of change of the function at the value x equals 2. Now, this is going to sound really goofy because you're going to be like, wait a minute, still at 2? We know the slope of the tangent at 2 is 0. So the instantaneous rate of change of the function, also 0. From part B, right? From way up here, g prime of 2 was 0. So the instantaneous rate of change of the function is 0. In the homework, you're going to get asked a lot of questions that are going to feel really kind of redundant. You're going to be like, this answer is 0, and this answer is 0, and this answer is 0. And the reason that we've assigned these problems is so that you can get used to the idea that if I ask you for the slope of the tangent, I want the derivative. If I ask you for the instantaneous rate of change, I want the derivative. So there are a lot of things I can ask for where you need to know, oh, the derivative, right? And they're going to be more and more. As we go on through the rest of the class, you're going to have more opportunities to find derivatives. So there are going to be more things. I'm going to say, find the marginal cost. And you're going to say, oh, the derivative. And I'm going to say, find the minimum point. You're going to say, oh, the derivative. Pretty much the derivative is going to be the answer to everything right now. So the problems will be kind of painfully easy for a little bit, just until you get used to it. Okay, would your answers to B and D, B is way up here, this one, sorry, and D, this one, change at a different value of x? Yes, because the derivative was 2x minus 4 is not constant. Because there's an x involved, that means that when x equals 1, the derivative is 2 times 1 minus 4, negative 2. And if x is 10, then the derivative is 20 minus 4, 16. So as you change x, you change, as you move around in this original function, you change where the tangent line is. So there are going to be a lot of different derivatives with this one, slightly different. Okay, you guys have made it. This makes a total of almost an hour of solid math calculus theory. Give yourself a pat on the head. Give yourself some nice juicy fruit or some lovely vegetables. Get some exercise. Maybe read a nice book. Oh, heck, watch another fun video on YouTube. And know that I think you're awesome and amazing. And hopefully that was the hump. And now that we're over it, the rest of the class hopefully will make a little bit more sense. But feel free, if this is really frustrating and you're just like, I can't get it, come to my office hours. Hit me up on email and Pronto and Canvas. Let me know. Tell me that you have questions, and let's see if we can make it make sense together. Woohoo! You guys are awesome. Math on.